Did you say, can I borrow a pen, please? Oh, man. To be fair, she brought a calculator. Yeah, and she brought a brain. You know what? I applaud your confidence. I need a pen. Stood all up here. I know it all. Okay, so this is example 4. So if you've done the summary notes from last lesson, of course, if you weren't here last lesson, one of the things you would have done on the weekend is catch up, right? Of course you would have. Between Thursday and now, you would have caught up. And because you've caught up, you just put in the rest of these summary notes down. And of course, if what I just said does not apply to you because you did not catch up, then make sure you leave some space so that you can put in the rest of the summary notes, which are on Google Classroom. So this 4th example here, we're going to a division. We've got 10 root 15, 5 root 3 over 5 root 3. So just a reminder that often in mathematics, specifically in algebra, but this is another example which is algebra-like, but it's not, is we don't tend to use the division symbol. We tend to write our division as a fraction. So if we have 10 root 15 over 5 root 3, this is the same as saying 10 root 15 divided by 5 root 3. Okay, so cancel down the rational part. So cancel down simply means you're comparing the numbers, finding a common factor if there is one other than 1, and then dividing both of those numbers by that. So for example, with 10 and 5, what's the common factor? Starts with F and rhymes with hive. Yay, 5. So I'm going to divide the bottom number by 5. That leaves me with 1. I don't normally write in 1 because 1 times anything is just itself, right? So, but I'm going to write it in just for the notes. And then 10 divided by 5 is 2. So I've cancelled that down. And then I've also said cancel down the third part. So again, just comparing the square roots there, I've got 15 on top and 3 on the bottom. What is the common factor for 15 and 3? Starts with T, rhymes with me. 3. Great. I just love how I'm basically telling you what it is, and I'm still only getting feedback from the same people. Please feel free to contribute in class, guys. So 3 goes into itself once, and 3 goes into 15 3 times. We good with that? Will, you good there? Cool. Okay, so what does that leave us with? Sorry, I'm just making sure I wasn't going anywhere with that. Hang on. Okay, I'll go on to the next. I'll leave it zoomed out now. Yeah, thank you. In case it's not clear by now, I don't try to trick students very often. I just make mistakes all the time. So that was a mistake. Thank you. I don't try to trick you. So that leaves us with 2 root 5 on the top, and 1 times 1 is 1 on the bottom. We okay with that? 2, and this is not an example. I don't know why I chose this one. Simplify the third if possible. But that's the same instruction as I had last time. But root 5 is as simple as I can get, right? There is no square number that goes into 5. And so the answer is just 2 root 5. And I'd be very happy for you to go from the question to the answer with this. You don't have to do that middle step like I did just then. That's really just for the notes so you can sort of see what's happening there. Okay, before I go on to another example, I think I've got one more example. I want to ask if there are any questions. No, I don't want to ask. I just did. Are there any questions about that one? Want to see something a bit trickier? Yeah. Example 5. 3 root 42 over 15 root 6 times root 28. Now, there's a few ways to approach these problems. And as you become more sophisticated with your maths, you'll learn which way to go first. One first step might be to simplify your surds first. So root 42, is there a number, a square number that will go into 42? Is there a square number that will go into 28? That kind of question. There may or may not be, but that may be a good first step. But looking at it, I can sort of see already that I know that 6 goes into 42, right? How many times does 6 go into 42? I think it was a third voice I might have heard then. Yeah, 7. I don't know who the third voice was, but thank you, whoever that third voice was. So I can say 6 goes into itself once, and 6 goes into 42 7 times. I'm so sorry. I've just done exactly what the opposite way that I said to do it in the last. Not that it matters, but I said cancel down the rational part, cancel down the surds part. I'm doing it in the opposite order. It doesn't matter, but I'm sorry if that's confusing to some people. I'll zoom up so you can see it. You okay with that? Keep doing it. As long as it's under the square root sign, you can keep cancelling down. So I've got root 7 here, root 1 here, and root 28 here. So does 7 go into 28? You sure? Yeah, of course it does. How many times does 7 go into 28? Yeah, that was more voices again. Thank you. Appreciate it. I really do. So I've got that. Now I've got root 1, and root 4. That's about as good as I'm going to get under the square root signs. So I'll switch to green and Rooney, and I'll do the same thing with the numbers now. I've got a 3, and I've got a 15 there. There's a common factor there, isn't there, of 3. I'll stop being too silly, and I'll just do it. So 3 goes into itself once and goes into 15 5 times. So a lot of cancelling down there, very messy, isn't it? But basically that's how I would do the problem. I would do as many cancel downs as I could and then just sort of mop up and see what I'm left with. So I'm left with 1 here. Oh, the whole thing is just 1, isn't it? I've got 1 root 1. I would never draw this. I'm going to do this for the example, but I would never actually write this because we all know what 1 root 1 is, right? What is it? 1. Yeah, is that okay with everyone? Cool. On the bottom, what am I left with? Oh, I've got a 5 here. I've got a 1 here. These are all times together. So I've got 5 times 1 times root 4. Yeah, but again, I would go straight to 2, but I'm going to go just 1 little step just for the notes, really. 5 root 4 on the bottom. And now I'm going to simplify. 1 root 1 is just 1. 5 times root 4 is 5 times 2, which is 10. So that whole big mess is just 1/10. What do you reckon? Any questions about that? Okay, everyone put their pens down for a sec. That's because I want to make sure you're not going to write. Root 3 plus root 2 over root 6 plus root 8. So 3 goes into 6 twice. 2 goes into 8 4 times. So that leaves me with 1 plus 1 on top and root 2 plus root 4 on the bottom. Root 4 is 2, so I'm left with 2 on the top and root 2 plus 2 on the bottom. Everyone happy with that? Great. Can you please, let me see now. Let's do it this way. For those who, no, I won't do it that way. If you are on my left, so this table onwards, can you please get your calculators out and work out what that is, which is, this is how you do it on your calculator, root 3 plus root 2 divided by root 2 plus root 8. Use your brackets like that. So this onwards, can you please use your calculator and come up with a number? And just these few people here, can you please work that out, work this bit out on your calculator? 2 divided by root 2 plus 2. Go. Just keep the calculator on your the answer you get on your screen. The reason why we're doing it multiple times is because we can then confirm in case someone makes a mistake. I'm going to pause the video while I do this. What did you get for your calculation? Sorry? 4,124? Oh, 4.24. I think you said 4,124. 4.24. Can I have some confirmation with nods on this side of the room if that's what you got as well? Not getting many nods here, so maybe not. Andy, what did you get? Entered the wrong numbers? Yours is definitely wrong. What about you? Is May the only one who actually got an answer? Andy, what did you get? What did you get? 2. Can't be just 2. Root 3 plus root 2 divided by root 2 plus root 8. .59. Can I have some nods for 0.59? What did you get? 0.74. 0.74. Can I have some nods for 0.74? Yeah, okay. It sounds like 0.74 is the answer that's most right. I don't care if you got things wrong. It's all right. It's no big deal. Yeah, 4.24 probably didn't look right when I think about it. So 0.74 doesn't matter. 0.74. We'll go with that as consensus. I think not that mathematics is by consensus, but enough people got 0.74. What about on? Oh, I thought I pressed record. I have. I just didn't untab that. Okay, cool. So we've got 0.74 on this side. And Hugo, what did you get? 586. So 0.59 roughly. Nods or, yep, okay, cool. So maths sucks, doesn't it? Because I just told you maths is consistent, but we've just got 2 different answers there. So either there were calculation errors made in the class, or the universe is about to explode because maths is not consistent suddenly, or we've made an error in our working outs here. Guess which one it is? Yeah, error. That's why I got you to put your pens down, because I didn't want you to copy this example down because it's not correct. What I wanted to point out is you cannot cancel down over addition. So you can't isolate this part and go, I'll cancel down this bit because that's nice, and cancel down this bit because it's nice, and then go on from here, because you cannot cancel down over addition. This cancelling down stuff here was absolutely fine because these are all multiplications. But here, there are additions involved here, so I can't cancel down across it. And you can see that. The calculator gave us 2 different answers, and the universe is still standing. So maths is consistent, therefore you can't do it. And there's a really simple reason why you can't do it, and that is, starts with B, rhymes with Frodmath. Yeah, bidmass, bodmass, whatever. Yep, bidmass. Okay? So bidmass says you cannot do, effectively, like if I rephrased bidmass, which is the order of operations, of course, you cannot do additions before you do multiplications. But what you're doing here is you're kind of ignoring the additions here, and like these have to be added. If we look at the way we have to put it into the calculator, there are brackets around here. So when we cancel down root 3 and, that should have been root 6 anyway. Anyway, trust me, it is different. If I'm cancelling down here and here, I'm effectively doing a division here and here, and ignoring the fact that they are actually bracketed expressions, top and bottom. Okay? Is that why it was 0.56 or whatever it was? Point 0.5, yeah, okay. 0.6 something, yeah. Okay, but they are definitely different anyway. So that's why you can't cancel down here, because effectively we have to bracket the top and bottom, and brackets always have to be calculated before multiplication and division. That's why. Okay, does that kind of make sense? I wanted you to have that experience, because I reckon it is the number one destroyer of good algebraic process because people will just cancel down things that look like they belong together, even though there's an addition between them or a subtraction. So make sure you don't make that mistake. I'm going to erase it from your memory. So how could you simplify that problem? Except you can't because they're not like terms. Oh, they were a little bit. What was the question again? It was root. Hang on. My brain's not that good. Root 3 plus root over root 8. Yeah, thank you. Nothing we can do. We can take root 8 and turn it into 2 root 2, right? So we'd have root 6 plus 2 root 2 on the bottom, but it still doesn't help us. They're still not like terms. So because these aren't like terms, I can't add anything up here. I can't add up anything here. I could use my calculator and get an approximate, which is what we all just did a second ago, but that's all we can do, right? All right. So be careful of that. You cannot cancel down over addition. I'm going to pause the video now, and I'm going to come back a little bit later in this lesson. No, I won't. That'll do for today's lesson. So what you're going to do now is you're going to work from your booklet, and you're going to complete the section on multiplication and division. Now, after that is a little section on estimation. If you have finished the multiplication division section, I will give you a one-on-one tutorial on how to do the estimation. Otherwise, I'll take the rest of the class through at the start of next lesson. So get into it.